In this video, we're going to give conclusion to the study of the beta and gamma functions, and we're going to be solving some problems as we can see in the screen now. So we're going to solve the first problem, second, third, and fourth, and hopefully we'll be covering all the possible kind of problems involving the beta and gamma function that we can find in our lives. So this first problem here is a problem which you have a root in between. This one we're going to have a logarithm function in between, and this one also logarithmic function, and this one is also when all is under a given root. And here the limits are very different, which is going to expose us to how to solve problems in which we have limits other than 0 to 1 and 0 to infinity. So we have covered two functions, gamma function and beta function. So in this kind of exercises here, it's not given which kind of function or which kind of problem we're dealing with. So we have to try to find out which problem we are dealing with and then apply the rules. So now, how do we know if you're going to use beta function to solve this or you're going to use gamma function to solve this problem here? Now, we should know the definition of those problems. We saw that the definition of the gamma function was that gamma of n was equal to integral from 0 to infinity of e raised to minus x into x raised to n minus 1 dx. So gamma has only one argument, which is n. So one of the tips that we can use here is that we see that here we have e, which probably may come from a logarithmic function because there's a relationship between logs and e. So we know that this function cannot be a gamma function because this function doesn't have something like this, nor something resembling this, or something that can lead to this, which should be log. So we can straight away go for the beta function. So how do we solve this? This is going to be our a. We have integration from 0 to 1. So you should pay attention that not always the limit should be our hint to know if we want to use beta or gamma function, because we may have to transform the limits as you're seeing in some other examples. So we're starting with a. This is x raised to 4, 1 minus root of x. All this raised to 5 dx. Okay, so how do we solve this? Now, the first thing is that we know that we're not going to use gamma function here because we don't have anything that can lead to e raised to minus x. Even if you make all manipulations we can do, nothing can just become like this from this expression. So we're going to try to see what the beta function can be. We know that beta of mn, beta function has two arguments. M and n is from 0 to 1 of x raised to m minus 1 into 1 minus x raised to n minus 1 dx. So this function is closely related to this function than to this function here. So therefore we're going to try to solve this using the beta function instead of using the gamma function. So how do we solve this? Now, before when we try to compare this function with this definition of the beta function, we can see that this part it's fine, this one is fine. But this part is not fine because instead of having only x, we have a root of x. And by the definition, we should only have x, not the root of x. So we have to deal with this x to make this a single variable. So in order for us to get this a single variable, we have to make an assumption. So what assumption is that? Is that take root of x as equal to t, right? So this means that x is equal to t squared, just square in both the sides. Okay, now if x is equal to t squared, this means what? This means that dx is going to be equal to 2t dt. So this is all the assumptions that we needed to get to this point here. So now the next that we have to do is to see if our limits will change. We have limit here from 0 to 1. So this is x is equal to 0, this is x is equal to 1. So we have to check here. If my x is 0, what's going to be my t? My t is also going to be 0. If my x is 1, my t is also going to be 1. So this means that our limits are not going to change. So this leads to limits are going to remain the same, 0 to 1, but now our function is no longer going to be in terms of x, but it's going to become in terms of t. So if t squared, if x is equal to t squared, this means that we are going to have here t squared raised to 4 into this 4 here is this 4 here into 1 minus root of x, we know that it's t, minus t raised to 5, and instead of dx we are going to have here 2t dt. So this is going to be equal to continue from here. 0 to 1 is going to be t raised to 8. We're going to have 2 into 4 raised to 8, and then we're going to have here 1 minus t, this is all raised to 5, into 2t dt. Okay, this is a constant. A constant can come outside, so we can see that this constant is outside from 0 to 1, and then you have this t here and also have a t here. So because this is going to be the same base, you just have to add the powers. This is t raised to 1, this is t raised to 8, so this is going to become t raised to 9, t raised to 9, and then this is going to become 1 minus t raised to 5, and then dt. Now if you look at this and look at the definition, we can see that it's basically following the same definition and everything is as it's supposed to be. So our next task here is to find what is m and what is n. We know that m minus 1 in this case is going to be equal to 9. So m minus 1 is equal to 9. This means what? This means that m is equal to 10. And also we can see that n minus 1 is equal to 5 here. So this means that n is equal to 6. Okay, so we can represent this equation as this. This is going to be equal to 2. And instead of us writing again all of this, we know that this is obeying the gamma function, and we have the two arguments. M we already have and n we already have. So this is going to become 2 beta of, instead of m we write 10, instead of n we write 6. So this is going to be 2 into beta of 10, 6. Okay, now we have also seen that there's some relationship that we use when we have beta function, which is a relationship between beta and gamma function, so in the other video. So which means that if we have beta of m n, that's going to be equal to gamma of m into gamma of n divided by gamma of m plus n. This is one of the properties we have seen. So this means that we can rewrite this in terms of the gamma function, because you know that gamma function has also a relationship with factorial. So this is going to be equal to 2 into gamma of the first one, gamma of 10, gamma of the second one, which is going to be gamma of 6, divided by gamma of 10 plus 6, which is 16. Okay, so this is going to be equal to 2 into gamma of 10 is equal to 9 factorial, and we have proved this in the video of the gamma function when we saw the properties. So this is going to be 9 factorial into 5 factorial, which is 6, divided by this is going to be what? 15 factorial. We have a video in which you prove all of this. Okay, and now you just have to solve this. So this is going to be 2 into 9 into 8 into, in fact, instead of doing this, what we can do is this. We keep it here, 9 factorial, and then here we have 5 factorial, divided by 15 into 14 into 13 into 12 into 11 into 10 into 9 factorial. Okay, so we can simplify this 9 factorial and this 9 factorial. So this is going to become 2 into 5 into 4 into 3 into 2 into 1. All of these is divided by 15 into 14 into 13 into 11 into 10. So which means that the final result is now we move into the second case. Now in this second case, you have to see, are we going to use beta or gamma function in this case here? In this case here we have log of something. So we know that what if you're making transformation from this, you're going to have e raised to something, because this is just the reverse of log. Because we're going to have e, it means that you're going to be using the gamma function, because the gamma function on its definition, it has an exponential expression on it. So therefore this is going to lead us to an exponential expression. That's why we're going to use it. So let's make our substitutions. So in order for us to make this, we have to always remember the formula of the gamma function, the definition. From 0 to infinity of e raised to minus x raised to n minus 1 dx. Okay, so now this is going to be equal to, let us take log 1 divided by y is equal to t, our variable t. So this means that 1 divided by y is equal to e raised to t. Why? We're taking out this, so it comes to the other side, becomes e raised to t. So that's why we know from this that whenever we make a substitution of this, we're always going to get e, and therefore we can with certainty try to go for the gamma function. So it's going to be 1 divided by y is equal to e raised to t. Okay, so but we don't want 1 divided by y. What is y? So if you see this, take this, it comes here, it's going to be dividing, and this y comes here, it's going to be multiplying. So this means that y is going to be equal to 1 divided by e raised to t. Now 1 divided by e raised to t can also be said as e raised to minus t. So this minus sign indicates that this all power here was in the denominator and now went up to the numerator. Okay, so this is fine. Now next step is this. We have to check about our limits. When y was 0 and if y tends to 0, what is going to be the tendency of t, and y tends to 1, what's going to be the tendency of t as well. So for y tending to 0, we have to see what is the tendency of t, and we have to check one of these here. For example, this one here, y tending to 0, t is not going to be 0, t is going to be tending to infinity if y tends to 0, because just take this, put it up, then divide this thing, you're going to have 1 divided by 0. Now 1 divided by 0, because this is a limit, you don't find the actual value, it's going to become an infinite value. It's going to be a very large value. So therefore this case here becomes infinity instead of, which is now something strange because our limit here starts from 0, and this one we're getting here, when this is 0, this is going to become infinity. And then now when our y is equal to 1, what is going to be our t? So basically what you're doing is just replace this y here, put 1, and then find the value of t for y is equal to 1. And then you see that when you do that, it's going to become 0. Now the thing I told you about how to find this thing is just have to find the new limits, you have to always replace that value with the limit of that variable, and then check how it's going to be your t. Fine. So these are our new limits. Okay, so then we have here y raised to q minus 1. We know what is the value of y. Y is equal to e raised to minus t. So this is going to become this, raised to q minus 1. And then here we're going to have log of 1 divided by y. We know that log of 1 divided by y is t, so this is going to become here t. This t here is raised to p minus q. Fine. But now the next thing that we have to find here was what is the derivative of y, so that we can get what is the equivalence of dy. So this, if you take from here, dy is going to be equal to, you're going to have this minus comes down, minus e raised to minus t dt, pretty much this. So this is going to become into minus e raised to minus t dt. Fine, and then you continue from here. So this is going to be here infinity, 0, and then here you're going to have e raised to, now you're going to make this multiplication between this and all of this. So it's going to be here minus t q, minus and minus becomes plus t, and all this is the power of e into t raised to p minus q into minus e raised to minus t. All of this is dt. Fine. Now this is not actually q, this is minus 1. My mistake. This is minus 1. This is not q, this is 1, because this was 1 here, not q. P minus 1. So we have this. Okay, now as you can see, now this is a minus sign. This minus sign can come outside because it's from a constant, which is minus 1. So this is going to become minus integration from infinity to 0 of you can see that we have here e can have also e. So because this is same base, we just have to add the powers. So this is going to become e raised to minus t q plus t minus t, because we're adding this power of this onto this one here, and then all of this into t raised to p minus q, not q. This is not q, sorry, this is minus 1 d, this is not dx, this is dt, this is dt, not dx, this is dt. Yeah, so this is what we get now. But now we can see is that this is not the limit we want, and we have a minus sign here. In order for us to meet this minus sign here, we can simply flip the limits. So if we flip these limits from 0 to infinity, we remove that minus sign here, and we're going to have now whatever the expression was, same expression is going to be there. So it's going to be minus t cubed plus t minus t. So these two are cancelling each other. So this is going to be equal to 0 to infinity, integration from 0 to infinity of minus t cubed into t raised to p minus 1 dt. But still, this doesn't fit to the requirement to become a gamma function because of this part over here. In the gamma function, it's supposed to be only x, not minus something x. Therefore, we are going to make also another assumption here. So we are going to say that we're going to take tq is equal to x. Okay, if tq is equal to x, this means that t is equal to x divided by q. Okay, so dt you can write from here, dt is going to be equal to, dt is equal to x, derivative of x is 1, so it's going to be dx divided by q. Now we come here and do replace here, but as we're going to do that, because we're trying to change the variables now, we have also to check the limits. Okay, so if this t is 0, what is going to be x? It's going to be 0 as well. This becomes 0, q into 0, 0, x is equal to 0. So the limit, the lower limit remains. If this is infinity, you're going to have q into infinity, so x is going to be infinity as well. So the limit remains. This is 0 to infinity of e raised to minus tq. So it's going to become e minus, instead of tq, we know that tq is equal to x, so this is going to become x. Okay, now we have here t raised to p minus 1. You know that t is equal to this, x divided by q. All of this is raised to p minus 1. And then our dt is equal to dx divided by q. Now we're expressing our function in terms of x. Okay, so this is going to be equal to, we know now that this is 0 to infinity, this is e raised to minus x, and this is the same thing as saying x raised to p minus 1 divided by q raised to p minus 1, okay, into dx divided by q. So this is equal to, this is a constant and this is also a constant, and as you can see, this constant here is an exponential and the base is q, this one is also base q, so it means we can just add this base and the powers and then take this base outside. So this is going to become 1 divided by q raised to p minus 1, which was this one here, p minus 1, plus 1 now from this q here, plus 1. All of this comes outside. We're going to have here 0 to infinity of e raised to minus x. Now this is no longer here, we only have this part here, x raised to p minus 1, and then all of this is going to be dx. So now we have found our expression which conforms to the definition of the gamma function. So this is going to become equal to, now as you can see here, this is minus 1 plus 1, so this is going to become 1 divided by q of 0 to infinity of e raised to minus x, x raised to p minus 1 dx. And now as you can see from this, we have here p. P is in place of what? This p is in place of n, and So because this p is the place of n definition of the gamma function, we can now say that 1 divided by q is equal to gamma of, this is in place of n, so instead of n we write here p, which can also be said as gamma of p divided by q, and we have found the solution. Now we go for the third case, call it C. In the third case, what we have is integration from 0 to 1 of x log of x, all of this is raised to 3 dx. Okay, and we want to solve this thing here. Now, once again, we know that we're going to have here log of x something, and there's this relationship with log that whenever I have log, if you pass to the other member, it's going to become e. So we already know that because of this log here, we are most likely dealing with the gamma function. Okay, but first we have to transform this into something similar. So let us take we're taking log of x, we are taking it to be equal to our variable t. Okay, but in this case here we are going to take it as minus t, because we know that we're going to have e raised to t, right? Because of this, it's going to be e raised to t, and we already know that it's going to be e raised to t. And in the gamma function, this is the gamma function, let me make the definition here, 0 to infinity e raised to minus x, and then this is going to be x and minus 1 dx. Okay, so if I make this log of x is equal to t, then my x is going to become e raised to t, but I know that whatever this value I'm getting here, this t, it's something which I want to replace for this case here, for this side of the function. So instead of saying log of x is equal to t, I can say log of x is equal to minus t, so that x is going to become e raised to minus t, which means I can directly come to this point here in my substitution. So that's why instead of taking log of x is equal to minus t, I'm taking log of x is equal to, instead of log of x is equal to t, I'm taking log of x is equal to minus t. If you don't do it, you're just going to add 2 more steps or 3 more steps in your equation, but then you're going to be the same value. Okay, so this is what we get here. Now the next thing that we have to do is now find what is dx. If this is x, then we're going to find our dx, which is going to be equal to minus e raised to minus t dt. Okay, and now I have to check our limits. Fine. Now we're going to check our limits. When x tends to 0, for example this x here as 0, what is going to be the value of our t? We should know that x is equal to the same thing as 1 divided by et. This is the same thing as this. Now when this x here is equal to 0, so what you can do is that you take this here, you put it up, and this x you put it down. So we're going to have e raised to t is equal to 1 divided by x, and this x is tending to 0, so it's becoming increasingly small, which means you're going to divide 1 divided by a very small number, which is going to become a very big number. So this is going to tend to infinity. So we are going to have here, this is going to be equal to, instead of 0 which we're having here, now this limit is going to change to infinity, which is what we get. And then in the upper limit, we just have to put 1 here and then see what is going to be the value of our t, and it's going to be 0. So this is going to become 0. So we have an inverted limit of what it ought to be. Then we continue. Now x into all of this thing. Okay, x is e raised to minus t, e raised to minus t, and then we know that log of x, this one here, is minus t into minus t. All of this is raised to 3, and then dx here, we know that dx is equal to minus e raised to minus t dt. Okay, this comes here like this, and we have here this minus sign here. This minus sign, if you want it to disappear, what you can do is just flip the limits. If you flip the limits, you're going to have 0 to infinity e raised to minus t and this becomes e raised to minus t dt. That minus sign is gone now. Okay, so now we have to continue with this. Now if this is e raised to minus t, so basically what you can do is that we take that 3, we put it inside. Okay, Now we see this same base as this same base, so you just have to add the powers, but this is a negative one, so it's going to be minus 2t minus 1t. So this is going to become, this is what we get now. Then we have here, this is a minus, so this minus sign is also to come outside. But the gamma function has to be e raised to minus x alone, not minus x something or 4t, 2x or ax. So I have to transform this into a single variable, which in this case we can call as our variable x again, because we're not dealing with x here, you can just revert back to x. So we're going to make this assumption: 4t is equal to x, which means now we're going to replace all this by x. Okay, if 4t is equal to x, this is going to mean what? This is going to mean that t is equal to x divided by 4. Okay, if this is x divided by 4, now we have to find what is going to be our dt. So our dt is going to be equal to the x divided by 4. Then we can come here and continue solving our problem. Going to be minus 0 to infinity of e raised to, instead of minus 4t, we know that 4t is equal to x, so it's going to become minus x. And then I'm going to have here t raised to 3, which is now replaced by x divided by 4 raised to 3. dt becomes dx divided by 4. This is the same thing as with this. So this is 4 raised to 4. Okay, so this is going to be equal to minus, this is these are all constants, so it becomes 1 divided by 4 raised to 4 of 0 raised to infinity of e raised to minus x of x raised to 3 dx. And this is our final result. But we know that this is supposed to be n minus 1, so basically we have n minus 1 is equal to 3. So this means that our n is equal to 4. So therefore, we can say that this is equal to 1 divided by 4 raised to 4 gamma of 4. And this is done. If you had to guess which kind of function we'd use here, we just go directly for the beta function. Why? Because we don't have log and don't have an exponential term here, so this is going to be easily a beta function. Okay, so the first thing you have to do now is to start with our assumptions. Our assumptions are going to help us to translate this into something much simpler to do. So because we suspect this to be beta function, let us first write the formula of the beta function, which takes two arguments, beta. As you can see, this is more close to this than this. So in our initial assumption, we're going to try to assume this to be another variable, because we want to keep this thing as it is because it's closer to this. So this becomes, when this x here is equal to 3, t is going to be equal to 0. 3 minus 3 is 0. X is equal to 7. 7 minus 3, 4. So this is going to become this. Zero to 4. Okay, this is going to be equal to 0 to 4. Now we have to try to remove this root here. Okay, so this is going to become whatever is inside t 7, it's no longer 7 actually. It's going to become 4 minus t, as you can see there, raised to 1 divided by 4 dx, equal to 0 raised to 4 of t raised to 1 divided by 4 of 4 minus t raised to 1 divided by 4 dt. Okay, now we got this. Now, is this close to the form of the beta function? Yes, it is close to the form of the beta function, which is this one. But the issue is that though we may have here this, which is correctly representing this, here was supposed to be 1 minus x, and here is not 1 minus x, it's 4 minus something. So instead of 1, they're having 4, so we have to find a way of getting here 1. And the next thing is that the limits are from 0 to 1, and this limit is from 0 to 4. So therefore, this is not done yet. So we have to try to find these limits and this expression in the equivalent fashion. So in order for us to do that, let's make an assumption. Let us take some assumptions here. So we have to think which assumptions can we take that will make this life, solving this thing, easier than expected or easier. So one of the assumptions we can make is that we can take t as for y. Then if you take t as for y, dt is going to be equal to 4 dy. So we're taking it from t to make it is equal to y. Okay, and so what is the overall idea here? The overall idea is that first we're trying to work out these limits to become 0, for this one to become 1, this to remain 0, and we're also trying to make this one to become 1. Okay, so how is it going to be? If t is equal to 0, y is going to be equal to 0. If this t is equal to 4, so we're going to have 4 is equal to 4y, which means y is equal to 4 divided by 4, y is going to be equal to 1. So this means that our limits are now good from 0 to 1. Now the next aspect is that because of this 4y here, if you replace it over here, you're going to have 4 and 4, which is easy to make common. But we are going to see this. T raised to 1 divided by 4. Now we know that t is equal to 4y raised to 1 divided by 4. And then 4 minus, instead of t, what we have is 4y 1 divided by 4. Okay, this is going to be equal to, this 4 is a constant, so you can take it directly outside. We have here 4 integration from 0 to 1 of, this is going to be equal to what? This is going to be equal to 4 raised to 1 by 4 into 4 into y raised to 1 divided by 4. So this is going to become 4 1 divided by 4 into y 1 divided by 4 into 4 minus 4y. So what you have common here, what you have common is 4, which is going to be equal to 1 minus y. And then this is going to become 1 divided by 4 into dy. So you can see that now we're going to have something like this, no longer 4 minus something. Okay, so this is going to become this. This is going to be 4 into, this is 4 raised to 1 by 4, so it's going to become 4 raised to 1 divided by 4. So this one is taken out. The next one to be taken out is this one, which is also going to be 4 raised to 1 by 4. It's going to become 4 into 1 divided by 4, and then it becomes 0 to 1. This is already outside, this is already outside, so what we're going to have here is y raised to 1 divided by 4 into 1 minus y raised to 1 divided by 4 dy. You can see here that we have a common base, okay? And these two here have a common base, so you have to add this exponent. So it's going to become what? 2 divided by 4. 1 plus 1 divided by 4, because they have the same denominator. So 2 divided by 4, which is the same as saying 1 divided by 4 plus 1. This 1 divided by 2 actually, plus 1. So this can also be represented as 4 raised to 3 divided by 2, because now we're taking LMC of these ones, because the power is constant or is the same. Okay, is equal to 0 to 1 of y raised to 1 divided by 4 of 1 minus y 1 divided by 4 dy. Okay, so this now obeys completely to the definition of the gamma function, and this is for the m and this is for the n. So we know that m minus 1 is equal to 1 divided by 4. If m minus 1 is equal to n divided by 4, so we can now assume that m is going, not assume, but m plus 1. Okay, so this is going to take 4 here, multiplying, going to have 4, so this is going to become 5 divided by 4. Okay, and then I'm going to have here n minus 1 is equal to 1 divided by 4. 1 divided by 4. But this is basically the same thing as this, so you can say that n is also is equal to 5 divided by 4. So we're going to have here, this is equal to 4 raised to 3 by 2 beta of, what is our m? M is 5 divided by 4. What is our n? N is 5 divided by 4. And it goes like this. But we know that we have the relationship between the beta and the gamma function to find the actual value of this. So that is going to be equal to 4 raised to 3 divided by 2 of into actually gamma of 5 divided by 4 into 5 divided by 4 divided by adding these 2 here. So gamma of 5 divided by 4 plus 5 divided by 4, it's going to be 10 divided by 4. And this is going to be the result.